MS Ramaya University of Applied Sciences.
Hi viewers, let us discuss on potentiometric estimation of FAS. Potentiometric titrations are based on variation of potential during a reaction. This measurement is governed by Nernst equation. Potential of system is controlled by ratio of concentration of oxidized to that of reduced species. As reaction proceeds, potential changes more rapidly near the end point. Pipette out 25 ml of ferrous ammonium sulfate solution into a beaker. Add 1 test tube full of dilute sulfuric acid. Immerse the calomel platinum electrode assembly into the FAS solution. Connect the electrodes to the potentiometer. Fill burette with standard potassium dichromate solution. Record potentiometer reading before the addition of potassium dichromate solution at 0 volume. Add 0.5 ml of potassium dichromate to the beaker. Stir the solution carefully and measure the potential after 15 seconds. Continue the procedure till the potential increases rapidly and take 5 to 6 readings further. Plot the graph delta E by delta V versus volume of potassium dichromate to find normality and concentration of FAS. Care must be taken while stirring to avoid breakage of expensive electrodes.
Hi students, today we are going to conduct the experiment potentiometric estimation of ferrous ammonium sulfate using potassium dichromate solution. So using this experiment we can determine the concentration or the amount of FAS present in the given solution. For this experiment the apparatus required are a burette. This is a burette into which we are taking standard potassium dichromate solution, and then we will be adding 0.5 ml increment of potassium dichromate solution into the analyte solution. A platinum electrode. This is a platinum electrode which works as a working electrode. Platinum is most stable element and we use this as electrode in redox reaction because in acidic medium it won't corrode, and also it effectively works as a catalyst for the redox reaction. A calomel electrode, which is a reference electrode. A pipette. This is a 25 ml pipette. Using this pipette we are pipetting the analyte solution and transferring into the beaker. A funnel. This is a funnel used to transfer potassium dichromate solution into the burette. This is the analyte solution, ferrous ammonium sulfate, where the concentration is unknown. Here iron is in Fe2 plus state. A beaker is required. This is the beaker into which we are taking a known quantity of the ferrous ammonium sulfate solution and half test tube of sulfuric acid to provide the acidic medium. Dilute sulfuric acid is required. This is dilute sulfuric acid where we are adding a half test tube of this dilute sulfuric acid into the analyte solution which we have taken in the beaker. This aids the redox reaction happening between Fe2 plus ions and the dichromate ions. And this is standard potassium dichromate solution which we are taking in the burette where the concentration of this is known. This acts as an oxidizing agent. This is the distilled water bottle. This is the distilled water where using this distilled water we are cleaning the beaker, burette, pipette and the glass rod. Before starting the experiment, let us clean the apparatus first. So let us clean the beaker. Funnel. And the pipette needs to be cleaned. Then the burette needs to be cleaned. Now we have cleaned the apparatus, then we have to start the experiment. Before adding the reagents, let us switch on the instrument so that it gets stabilized. Now let us fill the standard potassium dichromate solution into this burette using funnel. Add the reagent slowly. So we have taken the potassium dichromate solution little above 0. Again we have to see that there is no air gap here. Then adjust this solution to 0 mark exactly. Now we have adjusted the solution exactly to 0 mark. Into the beaker we have to take the known quantity of ferrous ammonium sulfate solution. This is analyte. So using the pipette we are transferring FAS solution into the beaker. Take the solution little above the mark, which is here, and then readjust this to mark exactly. Slowly you have to adjust. Okay. You see that all the solution from this pipette is transferred into the beaker. At the end few drops still will be there. You can just tap the tip of the pipette to the wall of the beaker so that last drops will come out. So now into this FAS solution we are adding dilute sulfuric acid, half test tube. Now we have to place the platinum and calomel electrode assembly into the solution. Wash the electrode little bit here and here itself, and take this out, and then place the analyte solution having FAS and sulfuric acid. Now we have placed the electrodes into the solution. adjust the position of the burette exactly into the beaker. Now let us start the experiment. So before adding potassium dichromate solution into the beaker, we need to record the potential value, and then we should start adding 0.5 ml increments of potassium dichromate solution into the beaker. So now first value will be recorded, and then we are going to add potassium dichromate solution. So 0.5 ml is added. So each time we have to mix well. We are using plastic straw to mix the solution. We can record the potential value for this reading. Again add 0.5 ml, mix the solution, then record the stabilized reading. Likewise, we have to continue the procedure. At some point there is a steep rise in the potential value. Okay. So we can see initially the gradual rise in the potential value. Further, after the steep rise, we have to take 4 to 6 readings, and then we can stop the experiment. So after recording the values, you have to calculate delta E values, delta V values, and then delta E by delta V values from the given tabular column, and then you have to plot a graph of delta E by delta V versus volume of potassium dichromate, from which volume of potassium dichromate required to react with the given FAS solution. After which you can calculate normality of FAS and concentration of FAS of the given solution. So this ends the experiment.
At MSR UAS, we spark your imagination unlike any other.